The U.S. aviation system is a modern marvel and sets the standard for the rest of the world. The efficient operations of the airspace system affect our entire economy. The U.S. aviation sector employs 12 million people and contributes more than 5% to our gross domestic product, representing more than $928 billion. Because of aviation's importance, the FAA is continually looking for ways to improve safety and efficiency. We recognize the value of aviation in our own lives and to the U.S. economy, but everyone gets frustrated with the extent of delays that can occur from the ever-increasing demand. We need a surface solution for the aviation infrastructure that's becoming overburdened with more and more flights, and we need a system that will smooth out the taxi demand to the runway. The FAA is using 3 very important tools that enable air traffic controllers to communicate better with the users of the airspace and make collaborative decisions to improve efficiency. We are using Traffic Flow Management System, or TFMS, Time-Based Flow Management, or TBFM, and the game-changing tool we're discussing today, Terminal Flight Data Manager, or the TFDM system. TFDM receives information about the airport's surface area demand and constraints and shares that information with both the airline's data systems and airports, as well as the air traffic controllers. The net result is a system that allows for the efficient use of the taxiways and runways. The new information is now available in real time with electronic flight strips, or EFS. The shared information that the airlines provide is now integrated with EFS and communicated seamlessly between each of the air traffic control positions in the tower cab. The important information that is needed on that flight stays with that electronic flight strip. Sharing the information electronically with the electronic flight strips reduces the verbal coordination between controllers in the tower cab and increases controllers' heads-up time. More time spent looking out the window, therefore increasing safety. Think about this explanation like it was your neighborhood. What if every car wanted to back out of the driveway at exactly 7:15 a.m.? In no time, there would be bumper-to-bumper traffic before you even reach the main road and well before you reach the highway. Instead, what if each of these cars had shared their destination and the time they wanted to arrive before they left their home? Each car would be put in a virtual queue and back out of their driveway at their specific departure time without interference with other vehicles. Each car could then flow into traffic at an allotted point in time, then lead them to the on-ramp at a point in time, and then onto the highway. With a managed flow, each point in their route is connected back to the time they backed out of their driveway. And with fewer traffic jams and a predictable pace, drivers could use this extra time before departure to check email, walk the dog, pack a lunch, enjoy an extra cup of coffee, and an on-time arrival. All of this from shared information that can strategically manage both time and traffic. That is how TFDM works for aircraft. Through the sharing of more precise schedule data for each flight, TFDM creates this point-to-point connectivity that enables the system to accurately schedule an aircraft's departures according to a predetermined sequence. Watch this example of how TFDM will work managing departure flow. Currently, aircraft push back from the gate when they're ready and enter a queue that gets longer and longer as the departing aircraft get in line. The departure line gets so long that arriving aircraft cannot avoid the traffic jam and have to wait for the departure lines to be cleared before they can access their arrival gate. Now, compare that scenario with aircraft that are being metered. Each metered aircraft is given a specific time to enter the taxiway. Their pilot doesn't need to repeatedly throttle the engine, wasting fuel and releasing CO2. The actual takeoff time for the metered aircraft would be at the same time, or perhaps even earlier, than the unmetered aircraft. It's the difference between anxiously waiting on the tarmac or comfortably waiting inside the terminal. Over the life of the TFDM systems, TFDM will save over 313 million gallons of fuel and over 3 million metric tons of carbon emissions. That's the equivalent of a reduction of over 7 billion miles driven by an average passenger vehicle. That's the impact of TFDM. It's a much more efficient, more comfortable, and more environmentally friendly flight.